Welcome back to Research Methodology, the second part. Today we're going to be looking at analysing quantitative data. So the key points we'll be going through: data must be analysed to produce information. It's going from basically raw data to how to actually do something with it that can be understood, especially by other people, the person that's going to be reading your work. Computer software analysis is normally used for this process, and we will be talking about something about that of the software SPSS now with IBM. We talk about a slightly older version because that's the free one that can be acquired by students, so that can be beneficial to you. Right, data should be carefully prepared for analysis, and researchers need to know how to select and use different charting and statistical techniques. So it's making it presentable in a way that can be understood by the reader. Nice and clear method. So the main concerns: preparing, inputting and checking the data, choosing the most appropriate statistics to describe the data, and choosing the most appropriate statistics to examine data relationships and trends. So if we look at the main considerations: the type of data, maybe the scale of measurement, some of the things we've already gone into previously, data format for input to analysis software, the impact of data coding on subsequent analysis, case weighting and methods of error checking. So if we look at an example here, define the data type. So we can see here we obtain the data for a particular variable. So can that data be measured numerically as quantities? If yes, fine. If no, categorical data. Can the data be classified into more than two sets? So if no, then it's descriptive, dichotomous data. If it can, then these sets can be placed in a rank order. So if they can, then they are ranked, and that's ordinal data. If they can't, it's more descriptive, so a nominal data. Can the data be numerically measured as quantities? Continuing off from the previous one, if it can, then it's numerical data. Can the relative difference between two data values be calculated? If yes, ratio data, and then on to theoretically taken with a value within a range. If not, interval data. Again, can the data theoretically take any value within a range? If yes, continuous data. If no, discrete data. So if we look at a simple data matrix, we have the cases that we've been looking at. So identification number 1, 2 and 3 to make it easy. Then we have variable 1, 2, 3 and 4, which you will decide what those variables are, and then the appropriate numbers putting in each of those cases. So the main data categories for coding, remember what we said what coding is? It's just applying a number for a particular response. So numerical data, categorical data and missing data. So the final stages of the process of preparing, inputting and checking the data are entering the data. So rubbish in equals rubbish out, so be careful of that. Weighting cases, always take time to check for errors, including illegitimate codes, illogical relationships and rules that were followed to filter questions. So exploring presenting data. So exploratory analysis can include specific values or highest and lowest values, trends over time, proportions, distributions. Showing aspects of individual variables, specific values, highest and lowest, trends, proportion, distribution of values. So, and here we have an example, a bar chart again, so we can see quite clearly. In this case, we're looking at total carbon emissions by the European member states, and this seems to be a very logical way of presenting this. We can see here in thousands of tons. Now it obviously leaps out at us that the largest emitters of carbon dioxide are, well, first off we have Germany, then the UK, then Italy and France. And if we were to look at that, we can see these results very clearly and immediately. And also it gives us an option to be able to compare this immediately. If we just had a number, 880,000 tons, how much is that in comparison to what another country would be using. Is it a lot or not? So if we were to look at, say, the difference between, say, Spain and Portugal, so two neighbouring countries, Spain here seems to have 300,000, and that's in thousands of tons, so in other words, 300 million tons, and their neighbour, Portugal, has well under 100,000, or 100 million in this case. So clearly we can see a great difference. Now we have to, so this is presented, now is the question of drawing the certain conclusions from what we see presented here. Histogram, so in this here, customer spending per visit at a particular supermarket. So we can see the frequency, in other words, the number of customers, the more customers, and the amount that they would spend. So the majority of customers here, which seems to be around the 3,900 mark, or a little bit less, spend on average £60 per visit. Whereas the frequency, the number of customers, only about 250 spend £160 per visit. So we can obviously see something, we can draw some conclusions here. The amount of people that spend more money generally are less, but the mean seems to be, or the average of this seems to be, the highest amount that we have here is £60 per visit. Pie chart, so we have a breakdown of sales, which areas in this case, where do most of the sales come from? Well, we can see that it's quite clear the lightest colour there, which is the southeast. Not a particularly good scale for colour. I would recommend, instead of different shades of the same colour, it might be difficult to work out which is which, is to maybe use totally different colours, blue, yellow, etc. And there's absolutely no confusion there at all. So we can see here the northern area with 8, eastern area with 10, southwest with 17, Midlands with 22, and southeast 43. So clearly the winner there. So comparing variables to show specific values and independence, highest and lowest values, proportions, and trends and conjunctions. Comparing variables to show totals, proportions and totals, distribution of values, relationship cases for variables. Statistics to describe a variable focus on two different aspects, well, the central tendency and the dispersion. Describing the central tendency to represent the value occurring most frequently, to represent the middle value, or to include all data values. Describing the dispersion to state the difference between particular values, or to describe and compare the extent by which values differ from the mean. So we're using statistics to test for significant relationships and differences, assessing the strength of a relationship and examining trends. So in summary, data for quantitative analysis can be collected then coded at different scales of measurement. Data types constrains the presentation, summary and analysis techniques that can be used. Data are entered for computer analysis as a matrix and recorded using numerical codes. Codes should be entered for all data values, and existing coding schemes enable comparisons. Data must be checked for errors. Initial analysis should use both tables and diagrams. Subsequent analysis involves describing data and exploring relationships by using statistics. Longitudinal data may necessitate different statistical techniques. So that should help you with your data analysis. So we'll give you some more information shortly on the different software that can be used to help you in this process. Okay, thank you.